Okay, Michael Landis, back out here with my favorite vehicle, my Jeep Grand Cherokee. Today we're going to take a look at a couple of sensors, coolant sensor and an intake air temperature sensor. They help control the amount of fuel that we get. They help control transmission shifting. They help control how much fuel the engine's going to get in order for a cold start, or if the engine's warm, we need less fuel with it. So we're going to use that information to make a lot of fuel calculations, but we're also going to use it for some other items, even air conditioning. If the engine's really, really cold, we don't want to use air conditioning. So we're going to disable the air conditioning. So we'll use these temperatures to know what the temperature of the air is that the engine's running on, as well as what the temperature of the engine itself is. Our PCM uses that to help control a cooling fan. If we have a electrical fan, we'll ramp speed up and down dependent of the fan, dependent on the temperature of the engine. How much cooling do we actually need? So let's take a look at these. We're going to look at them a couple different ways. Our coolant sensor on this vehicle is buried right down here underneath of the intake. Not really under it, but it's right here at the edge of it. If you can see my finger, it's right there. And so I have back probed our sense wire on the coolant sensors. Two wires, one of them gets 5 volts on it, one of them gets a ground, and the voltage will vary depending on the temperature. So as the resistance of the sensor changes, the voltage is also going to change. And I've also tapped into the intake air temperature sensor. This is the intake air temperature sensor, so I've also tapped into it so we can read the temperature of it. So right now, everything is turned off. The vehicle's turned off. My meters over here have even gone to sleep. So I'm going to turn those back on. And no voltage on them right now because they are asleep. We're going to go inside of the car here, and this is usually one of the first things I look at if I think I have a problem with a temperature sensor. If I can get the car while it's cold, then, and this vehicle hasn't been running, our coolant gauge says we're all the way down to cold, which I would expect. There's nothing wrong with this vehicle right now. We might put a problem in it, but right now there's nothing wrong with it. So I'm going to go into the data list, and we're going to pull up a couple of these items and see what we get out of them. So here's our data list, and what I'm going to do to make this more interesting is I'm going to pick a 4-graph screen. So this is going to allow this scan tool to read out 4 different graphs for me. And I'm going to scroll down here a little bit till I get to the coolant temperature and the intake air temperature sensor. Past it. So right up at the top, you can see the coolant sensor. I don't know if I can focus that any better for you. This camera is supposed to be on automatic focus, but it can't quite do it that close. So there's our coolant sensor. It says it is reading 4 volts. Our intake air temperature sensor, it said it is reading 3.79 volts. We'll call that 3.8 volts. So let's see how close we are to that. This is what the scan tool is saying that the computer is seeing. And there are times when that could vary. We could have a problem inside of the computer and it could be miscalculating what it's actually reading. So if I go back out here to our meters, here is our coolant temperature sensor. It is now reading 4.8 13 volts DC, and our intake air temperature sensor is reading 3.949. So we'll just round that off to, it's basically 4 volts also. So this one's reading 4.1, this one's reading 4 volts, little bit off. This one's off by 1/10 of a volt, and that could be a difference in the meters. We're only talking a 1/10 of a volt. A 1/10 of a volt difference here to the scan tool, and this one is about a 1/10.5 difference from here to the scan tool, maybe 2/10, and that's okay, we're still close. Now here's one of the ideas why I like to look at these two with the car cold if I'm looking at a problem, is notice our temperatures, our readings are really close together. One of them is saying 4.1 volts, one of them saying 3.949, basically 4 volts. Really close temperatures. Let's see what that comes out in the temperature scale. Here is one of the things I like to look for. If I think I've got a sensor that's out of range, if we've got a sensor that has an open circuit or has a shorted circuit, that's pretty easy. It's going to be 5 volts or it's going to be 0 volts. Really high voltage, really low voltage. Our gauges are going to read one extreme or the other. That's pretty easy. That's pretty straightforward. But what if they're not reading correct? I'm not getting the right temperature out of them. So, for instance, if I look at this one, it actually says here that I am reading at 1.9 or 19 degrees Celsius, which should be about somewhere around 67, 68 degrees, somewhere in that area. And the coolant temperature in the intake air temperature sensor, right now they're within about 5 degrees Celsius of each other, which is within 10 degrees of each other. That's pretty much what I'm looking for. If the engine is cold, it's sat overnight in the parking lot, then they should be pretty close when I start them up. So let's start it up and we'll watch what happens. I'm going to start it. Make sure all my stuff's staying good. And we're going to watch what happens to our voltage as well as our temperature. You can see them running across here. And what we're going to see is as this starts to warm up, these are going, our voltages are going to start to drop. These sensors are what we call negative thermal coefficient sensors. What that means, it's called an NTC sensor. And let me see if I can reposition these just a little bit, make them easier to see. So what that means is negative thermal coefficient means as the temperature goes up, the resistance of the sensor comes down. So if the resistance of the sensor goes down, then go back to Ohm's law. That means the voltage drop across the sensor is going to change. So negative thermal coefficient, if I have a cold engine, temperature is low, that means the resistance is going to be high. Resistance will be opposite of the temperature. So the resistance will be high, large voltage drop, and you can see as the coolant is warming up, we're now at about 3.5 volts, and you can see it slowly dropping as the engine warms up, and we're still at 3.9 on our Intake air. Intake air hasn't changed. The engine itself isn't hot enough. The radiator is not hot enough. On this vehicle, there's an inlet. The air inlet comes right in through here and through a duct into the air cleaner, so it's getting outside air. So our outside air temperature has not changed, but you can see we are almost down to 3 volts. About the time I get back inside, we're going to be down to 3 volts. So this graphing meter on the Modus keeps a couple minutes of time going, and you can see what's happening here on the graphing meter. Let me back out just a little bit, see if I can get a little bit better focus on it. And so you can see our temperature was at 4 volts. And now as the engine is warming up, it is slowly creeping down, and we're down to 2.8 volts. Hey, we were just about at 3 volts when we came inside of the car. Our temperature has gone from basically from 19 degrees Celsius to now we're up to 47 degrees Celsius. Now keep in mind 100 degrees Celsius is going to be 212 degrees. So 100 degrees is about where the cooling fans will turn off when the engine's running. And we are still at 3.75 degrees or 25 degrees Celsius on our intake air temperature. So it hasn't changed a whole lot. Now this is going to look like there's been a big, huge, fast drop, but this is only 1.5 volts. The whole scale rate here is only 1.5 volts. The scale itself is going to keep changing as in dropping down as the voltage drops down. So we're down to 2.4 volts, and what I'm really interested in more than the reading, and I care about this more than the reading. Yeah, the reading needs to be close. Reading needs to be close. If it's within 10 degrees of what you might actually be measuring, life's good, don't fret it. What I'm looking for is, notice everything is happening real smooth. There's no drops, there's no fast drops, there's no spikes. And that's what we're looking for when we look at this. Are we just continually changing smooth with no spikes in our reading? And if I go back out here and just get an update from our voltmeters, you will see this one's reading 3.8. Intake air hasn't changed. The temperature out here hasn't warmed up in the last 3 minutes. And we are down to 2.3 volts. We'll probably be down below 1 volt here in just a minute. So the engine is warming up. It's not warm enough that the thermostat is open, but it is getting warm. Top radiator hose, I'm sorry, has not opened up. It's not warm, so we don't have any coolant circulating yet because we're not that warm. Coolant's going to start circulating when we hit about 94 degrees Celsius, somewhere in that area. And right here, coolant temperature, we're at 64 degrees Celsius. But so you get the idea. This should slope off fairly normally. I shouldn't really see any spikes in it. We're still running 3.7 volts on the intake air temperature. It's changed about 2 degrees. That's okay, because there is some heat building up around the engine, so it is going to get a little bit warmer inside of the intake. And we're at a very low volume of air, so that's not going to change it much. So that's kind of what's happening with those sensors. We're going to take a look at manually testing this sensor, how we can manually test it, and then What's going to happen if we have a circuit problem?